Hello friends, in this video I'd like to solve the following problem from the Finnish High School Mathematics Competition Final Round 1999, problem number 3. We wish to find how many primes are there in the sequence 101, 10,101, 1,010,101, and so on. We have a sequence of numbers with alternating ones and zeros. My hints for this problem: since it was given on Mathematical Olympiad, there are probably not that many primes in our sequence, because showing that something is a prime is a hard task usually, not easily done by hand calculation. So there are probably not that many primes there. Second, it's a good idea to consider cases of an even and odd number of digits 1 separately. And finally, this formula for the sum of geometric progression may be useful, namely 1 plus q squared and so on plus q to the power k minus 1 equals q to the power of k minus 1 over q minus 1. So give this problem a try and I will see you in a... Okay, so I hope that you've managed to solve it. First of all, let's notice that 101 is a prime. In fact, it's the only prime in this sequence. Why? You shall see in a moment. So let's consider two separate cases. Case number one, odd number of digits 1. What happens then? Well, since our number can be written in this way, in decimal system, it's 1 plus 10 squared plus 10 to the 4th plus 10 to the 6th power and so on and so on. And the last digit, it should be visible that the last exponent will be divisible by 4. Why is that? Well, let's consider a few cases to see the pattern. 1, 0, 1, 0, 1. Here we have 10 to the power of 0. Here we have 10 to the power of 2. Here we have 10 to the power of 4. If I add another 2 ones, I will have 10 to the 6th, 10 to the 8th. And it's visible that the first digit represents 10 to the power divisible by 4. Okay. And now, using the well-known formula for geometric progression, it's the... How many terms are there? Well, maybe I will write it in a more suggestive way. It's 10. Yes, 1 plus 10 squared plus 10 squared squared plus 10 squared to the 3rd power and so on. 10 squared to power 2k. And now we can use the formula. It's just 10 to the power 2k, 10 to the 2nd power to the power 2k plus 1 minus 1 over 10 to the 2nd power minus 1. Okay, very nice. And now, what can I do? Now I will do the following trick. I will write it as 10 to the power 2k plus 1 squared minus 1 over 10 to the power of 2 minus 1. And now I will factorize it as 10 to the power 2k plus 1 minus 1, 10 to the power 2k plus 1 plus 1. Okay. And I will factorize the denominator. It's 10 minus 1 times 10 plus 1. Very well. And now, let's see that we can factorize it further, because this part, after using again the formula for geometric progression, the sum of geometric progression, it will be 1 plus 10 squared plus and so on plus 10 to the power 2 times 2 to the power 10 to the power 2k, while the second sum, because our index exponent of 10 is odd, we can write the second number as 10 as 1 minus 10 plus 10 squared minus 10 cubed, and so on. The last number will be plus 10 to the power 2k. And now it's visible that this number, this first number, is definitely greater than 1. And since k is greater than or equal 1, this number is also greater than 1. So this product cannot be a prime, because a prime number cannot be represented as a product of two numbers greater than 1. So we now know that this number is not prime. Okay, so we know what's happening in the case of odd number of ones, and now I will deal with the case of even number of ones. Case number 2. Case number 2, even number of digits 1. What happens now? Well, let's take our number 1, 0, 1, 0, 1, 0, 1. And moreover, let this number of ones be greater than 2, because we know that 101 is a prime. So we are now considering cases of 4 digits 1, 6 digits 1, and so on. Okay, so this number is 1 plus 10 to the power of 2 plus 10 to the power of 4 plus 10 to the power of 6 plus 10 to the power of 8, 10 to the power of 10, and so on. The last two terms will be 10 to the power 4k and 10 to the power of 4k plus 2 this time. And now we can see the following. I will write 1 plus, maybe I will write it in yellow. First two terms stay as they are, and from the next terms I can factor out 10 to the power of 2. From the next two terms I can factor out 10 to the power of 8, and so on and so on. I will move it a little bit. And the last terms will be, I can factor out 10 to the power 4k. In the parentheses, I will have 1 plus 10 to the power of 2. And in fact, it's just 1 plus 2. Sorry, I made a small mistake. There should be 4. So we have 1 plus 10 to the power of 4 plus 10 to the power of 8 plus 10 to the power of 12, and so on and so on. The last will be 10 to the power of 4k times 101. Okay, and now, since we have more than 2 digits 1, this first number, is definitely greater than 1 if k is greater than or equal 1. So if we have 4 ones or 6 ones and so on. So this number cannot be a prime either. This number is also not prime, which means that we have the only prime number in our sequence is in fact 101. Okay, so thank you for watching, and I will see you in the future, hopefully. Goodbye.